Imagine you are working with a curve. Sometimes you need the exact midpoint. Sometimes you need a point at 25% or 75% along the curve. Other times you have an object nearby and you simply want to find the closest point on the curve. And in some time, finding the point isn't enough. You also need the direction of the curve at the point to orient other objects. They all sound like a same problem. Find a point on curve. But in Grasshopper, each of these tasks is solved using a different component. In this video, we will explore the 3 most important ways to find a point on curve. Understand when to use each one and learn why choosing the right method can make your definition much simpler. There are 3 common ways to find a point on curve. Evaluate curve, closest point, point on curve. At first glance, they all seem to do the same thing. They return a point. But the way they find the point is completely different. Let's understand each one.
Hi, welcome to architectslearnings. This is my 26th video of beginner tutorial. If you are a beginner, please check out previous videos to get a grasp on what's going on. Let's start. Let's start with the curve. Just draw the simple curve. Then let's bring that curve into Grasshopper. The first component we are going to see about is evaluate curve. You can find this in curve analysis, evaluate curve, or you simply type on the canvas, find the component. So you can see there are 2 inputs and 3 outputs in the component. And first input is curve. Let's connect the curve to the curve. Second component is parameter. What is parameter? The nerve curve is based on mathematical equation. The parameter is part of that equation to derive the curve. For a simple understanding, you can consider the parameter as a time for the particle to take from one point to the end point. How in real world time is affected by black holes. The parameter is affected by the control points. So where the control points are so dense, the parameter slow down. When you change the control point, the parameter of the curve also will change. So before use this component, we have to parameterize the curve, because parameter work based on the domain. So let's reparameterize the curve. What it will do, it will set the start point as 0 and the end point will be 1. This is LCS. Now set the parameter also 0 to 1. You can find any point on the curve based on this. When you set 0 to 1, let's say there is 11 set of points. You can find any 11 points. But if you want more points on the curve, you just have to increase the decimals. With that, you can find any point on the curve based on this component. Let's set 0.5. You think this is midpoint. This will not be a midpoint because this is based on domain. The parameter is affected by control points. When you change the control points density or moving the control points, it will change the point also. As you can see, I am moving this point, it will change slightly the 0.5 parameter point also. The parameter is not equally distributed along the curve. It is concentrated where the control points are dense Mostly you cannot find the midpoint with this component. Now let's see what are the outputs. Let's connect the panel to the point. As you can see the point's coordinates. This is WCS. As you can see, this component changing the LCS to WCS. The second output is tangent. Tangent is used for find the direction of the curve at that particular point. Since this component giving the point location and the direction, we can use this component to orient objects. When you sweep, you have to place the profiles along the curve. We can use this component. And the third output is angle. Angle is in that particular point, the incoming curve and outgoing curve, the angle between those two curves given by this angle. Now let's see the second component to find the point on curve. For that we are going to use curve closest to point. You can find this component also in the curve analyze tab. As you can see, there are two inputs, point and curve, and it is giving three outputs, point, parameter and distance. As you can see, the second output is parameter. It is whatever the input we are giving in the evaluate curve, it is giving us a output. You have to use this component when you find the point on curve which is near to some kind of object. Let's set up one point and see how it is works. Let's place the point on Rhino. Let's bring that point to the grasshopper. Set one curve. Now let's connect that point to point input and connect the curve to curve input. As you can see, it created the point on curve. Whenever you are moving that object, or in this case the point, the nearest point also change. Let's see what are the outputs are giving. Let's connect the panel. As you can see, it is giving the point coordinates in WCS. The second one is the parameter. Third one is the distance between the 2 points. As you can see, the second input is 51, but our parameter what we have set is 0 to 1, because this curve what we have given to this parameter, we don't need to reparameterize. Let's see when we reparameterize what happens. When we reparameterize, as you can see, it becomes 0.33 something. Let's connect this to the parameter. As you can see, both giving the same point. Now let's just disconnect that. This is just for fun. Now let's go to the third component, which is point on curve. Let's type point on curve in the canvas. As you can see, it's kind of number slider which gives the midpoint. Let's connect the curve to the component. Basically, this component works like a snap tool. This component you will use when you directly find the midpoint, start point, or 1/3 of the point. Then you can use this. Only you need the point location. Then you can use this component. Let's set up parameter also 0.5. Oh, it's already 0.5. As you can see, this is also 0.5, but both the things are not matched because, as I said earlier, the parameter point is not always the midpoint. It based on control points. You can even adjust the control points to get closer to midpoint, but still it will be difficult. Let's see this output also. It is also giving the coordinate of the point. With these three components, we can find a point based on what your requirement is. If you know the parameter, you will use evaluate curve. If you want to find the point on curve based on some object nearby, then you use curve closest to point, which will give you the parameter, distance and point location. Then if you want directly find the midpoint or something, you will use point on curve. That's all for today. Subscribe for more content. Bye.